Welcome to today's problem solving section, that is uncertainty principle. So in this section we will solve some problems and we will learn the principles and procedures of this uncertainty principle, how to solve this problem. So let us see. If the uncertainty in the position of an electron is of order of 5 angstrom, calculate the uncertainty in speed. So we have to find the uncertainty speed, that is the V. So according to Huygens principles, we know that this is the one, delta U into delta X is equal to H by 4 pi m. So this is the actually formula of the principle. So we have to find the this speed delta U they have discussed. So here delta U is equal to put the value of 6.625 into 10 to the power minus 34 and divide by 4 multiplied by 3.14, and the mass of the electron is given here, that is 9.1 into 10 to the power minus 34, and here change in position, that is 5 angstrom. So 5 into 10 power minus 10. So on solving we will get answer here 1.14 into 10 to the power 5 meter per second. So this is our answer. Now question this one. A car weighing 3 into 10 power 3 kilogram is moving on the road and its speed is measured with an accuracy of 0.0011 meter per second, and its position is measured with the accuracy of plus minus 16, and is the Huygens bug uncertainty principle is valid in this case. So we have to see this thing, is it valid or not valid. So again see, so mass given here, mass is already, this is given 10 per 3 kilogram, and here delta U is also given, this is delta U is given here, and here position is also given here plus minus 16. So this is here 16 meter, so plus minus 16 meter, this position also given here. So we have to find here is the principle valid or not valid. So again to validity we have to write here delta X into delta U into multiplied by M is equal to H by 4 pi. If this is equal or greater than this one, then this is valid. So H by 4 pi is equal to how much? 6.625 multiplied by 10 to the power minus 35 divided by 4 into 3.14. This will give you 5.28 into 10 to the power minus 33 joule per second. So again, what is the delta X, delta U, delta M? So if you solve it, delta X into delta U into M, so this will give you, so delta X is given 16 multiplied by 0.0011, and here mass is given here, mass already we have taken, speed we have taken here, this is speed, and again 3 into 10 power 3 is the mass, that is the mass. So on solving we will get here 52.8 joule per second. So here delta X M into delta U, so this is here how much? This is here minus 33 and this is here 52.8. so definitely this is greater than this one, so definitely this is will be greater than H by 4 pi. This means the principle is valid. So this is, you can say, the uncertainty principle is valid in this case. This particle is having a mass equal to 10 power minus 11 gram, diameter 10 power minus 4 centimeter, and velocity is 10 power minus 4 centimeter per second. The error in measurement of velocity is 0.2%. Calculate uncertainty in its position. So U is given here, how much U? That is 10 power minus 4 centimeter per second. This is given, and the error in measurement is 0.2%. So we have to find the delta U. So delta U will be your how much? So 0.2, that is the divided by 100 into 10 power minus 4. So this will give you 2 into 10 power minus 7. So but delta U into delta X is equal to H by 4 pi into M. So this is the value. So again delta X is equal to H by 4 pi M into delta U. So we can put this value, that is putting this was, this is 6.625 multiplied by 10 power minus 27. We have to take the CGS system, 4 into 3.14 again multiplied by 10 power minus 11 multiplied by 2 into 10 power minus 7. So on solving we will get here 2.6 into 10 to the power 8 centimeter. So this is our uncertainty in position. So this is the third number. Now see the fourth number. The value of delta x and delta u for the particle are 10 power minus 3 and 10 power 6 into 10 power minus 24 meter per second. So this is the delta u respectively. Calculate its mass. So for mass again, delta x multiplied by delta u is equal to h by 4 pi m. This is the principle. So for you put here reverse mass here, mass this side, so it will be m divided by 4 pi into delta x into delta u. So you will get here, put this all value 6.625 multiplied by 10 to the power minus 34 and divide by 4 pi means 4 into 3.14 multiplied by 10 to the power minus 3. This is given here position, and v is given here 6 into 10 power minus 24. So you will get answer 8.79 into 10 power minus 9. So this is the mass. So this is our answer of this question number 4. What is the maximum precision with which the momentum of an electron can be known if the uncertainty in the position of electron is 0.001 angstroms? Will there be any problem in describing the momentum if it has a value of h by 4 pi a naught? What is a naught? A naught is the Bohr radius. That is the value of the Bohr radius. The first radius is 0.529 angstrom. So we have to find the momentum. So here again using the Heisenberg's principle, delta x into delta p is equal to h by 4 pi. So here delta x is given here 0.001 angstrom. So delta x is 0.001 angstrom. This means this will be your 10 power minus 30 meter. And delta p is how much? So delta p is 6.625 into 10 to the power minus 34, and here divided by 4 into 3.14, that is 4 pi into 10 power minus 13. So on solving you will get here 5.27 into 10 to the power minus 22 Newton second. So this is the delta p. So what is the momentum? So here momentum will be h by 2 pi a naught. So this is the formula momentum. So we will get 6.625 into 10 to the power minus 34 and divide by 2 into 3.14 multiplied by 0.529. This is the value of a into 10 power minus 10. On solving we will get here 2 into 10 power minus 24 Newton second. So what is the uncertainty momentum? So we can see here uncertainty in momentum will be about how much? So we can divide this one 5.27 into 10 to the power minus 22 divided by the 2 into 10 to the power minus 24. So on getting we will get almost values 263.5 times. So this will be this much times large as the momentum itself. This plus times large as the momentum itself. Which means that the why this is so, because the concept of Bohr's orbit has been replaced by the probability of locating electron cloud. So will there be any problem describing the momentum if it has a value of this one? So it will be different, because this may be this much large. Why? So already because the Bohr's orbit is, we have changed the Bohr's orbit and we are replacing its electron clouds. If you take the electron cloud, then there will be a difference in this momentum and that momentum. In an atom, an electron is moving with a speed of 600 meters per second with an accuracy of 0.005%. What is certainty with which the position of the electron can be located? So we have to find this certainty in the position. So again we can use this Huygens uncertainty principle. So delta x into m into delta v is equal to h by 4 pi. Then we can m into v. So this we have to find out delta x. So delta x is equal to h by 4 pi m into change in velocity. So what is the velocity here? So velocity we can write here 0.005 divided by 100 into 600. So this will be answer you will get here. So 0.05% by this one, so this will be 100. So 6 into 5 30 So we can write here 0.005 into 6, so we'll get here 30, so it will be a point, it should be 0.005, so here 5, so it will be a 0.03. so this is our velocity meter per second. Now we can put this value 6.625 into 10 to the power minus 34, and here will be 4 into 3.14, and the mass of the electron will be 9.1 into 10 to the power minus 31, and here velocity is given here 0.03. So on solving we will get answer 1.92 into 10 to the power minus 3 meter. So this is the uncertainty positions. Now next question, the position of the proton is measured with the accuracy of 1 into 10 power minus 11 meter. So find the uncertainty in the position of the proton. 1 second later, assume velocity of the proton is equal to velocity of the light. So in this problem we have to find the uncertainty in the position. So again same problem, delta x into delta v equal to h by 4 pi m, and you know delta this v is equal to how much? This is equal to delta x by delta t. This is distance by time travel. So here we have given time is also given and distance is also given, so we can put this value. So delta x is equal to h by 4 pi m, and this will be your delta x. So we can write here delta x naught. So here delta x naught into time. Now we can put all this value, 6.626 into 10 to the power minus 34. Time is given here 1 second. You can see here 1 second given here. To write the value 1 second, divide by 4 into 3.14 multiplied by mass is given 1.6, mass of the proton. This is the mass of the proton. 72 into 10 power minus 27 multiplied by 10 to the power minus 11. On solving we will get answer 3.15 into 10 power 3 meter. So this is the uncertainty in the position of the proton. On the basis of Heisenberg uncertainty principle, so that the electron cannot exist within the nucleus. So here we have to find out. Let us write this equation, and delta x into delta u is equal to greater than equal to h by 4 pi m. So this is the basically principle. Now here delta x means that is the radius of nucleus, that is equal to almost equal to minus 13 meter. This we have to take it, and electron is just near about the nucleus, so we'll take this distance, almost this distance, then we try to solve it. So here delta u of the electron, we have to find whether electron can exist within the nucleus. So delta u of the electron will be h by 4 pi m into 1 by delta x. So here 6.625 into 6 into 10 power minus 34 divided by 4 into 3.14 multiplied by 9.1 into 10 to the power minus 28 multiplied by 10 to the power minus 13. So this is the meter given, lighter meter. So this is the radius of the electrons or nucleus of the atoms, almost this much, and so on solving you will get here 5.79 into 10 to the power 12 centimeter per second. So now if you compare this with this speed of the light, so speed of the light is 3 into 10 to the power 10 meter centimeter per second. So this light is almost 100 more than 100 times of light. So from here we can conclude that since this is more than the 100 times the speed of light, that is not true. So this is totally impossible. Speed of the electrons can be this much is impossible. So we can say the possibility of, possibility of electron cannot exist in nucleus. How is it possible? Because already we have calculated that speed of the electron is less than the speed of the light, but here it is giving more than the speed of light. So this is totally false. Calculate the uncertainty in velocity of a cricket ball if its uncertainty in position is of the order of 1 angstrom. So here you we will use delta u into delta x is almost equal to h by 4 pi m. So here delta u will be, you can put this value 6.626 into 10 to the power minus 34, again 4 into 3.14 multiplied by, so here mass we have to find out. So mass is given here 0.15 kilogram. So this is minus 10 is the order angstrom. This is given here. So on solving we will get here 3.51 into 10 to the power minus 24 meter per second. So this is the speed of the cricket ball. Uncertainty speed of the cricket ball. Alveoli are tiny sacs in the lungs whose average diameter is 5 into 10 power minus 10 meter. So an oxygen molecule is trapped in a sac. The uncertainty in the velocity of oxygen molecule within the sac is, so here we have given 4 values. We have to find which value is nearest to the speed of the uncertainty in the speed of oxygen molecule within the sac. So first we have to find the average diameter, that is the positions. So here diameter of alveoli is equal to 5 into 10 power minus 10 meter. So we can use this value delta x into delta u is equal to h by 4 pi into m. So what is the mass of the oxygen molecule? So mass of the oxygen molecule will be, so it is given here, one oxygen molecule. This is the one oxygen molecule. So how to find the one oxygen molecule? So 32 divided by 6 into 6.023 into 10 to the power 23. This is the mass of the one oxygen molecule. So now you put this value. So delta u is equal to h is given here 6.626 into 10 to the power minus 34, 4 into 3.14, and the mass of the molecule already given 332 divided by 6.023 into 10 to the power 23. This is given here and multiplied by, so and the e delta u is given here. So delta u, not delta u, and delta x is given here, that is 5 into 10 power minus 10 meter. So on solving we will get here answer 1.99 meter per second, which is equal to 2 meter per second. So this is the speed of the oxygens within the sac. So answer A is correct.